Thank you everybody for joining. As I mentioned, good afternoon, good morning, depending where you are. Welcome to, and I should say happy summer. Welcome to this month's Produce Safety Educators Call webinar. Today we have Sean Fogarty from NECAFS to talk a little bit and provide us with an introduction to produce safety and hydroponic and aquaponic operations and available resources. And I have the chat going in case anybody has questions. Again, good to see a number of familiar faces. And Betsy, you can go to the next slide, please. Thank you. So just a couple of introductions to set the stage for this educators call. As a reminder, all participants are muted. There will be time for questions and discussion at the end of the meeting, but if you have questions, as you think of them, feel free to put them in the chat box or the Q&A. I will feed them to Sean at the end, or if I feel like it's a good time, I'll get him to pause. This session is recorded, and here we go, it is recorded. And the presentation will be shared via the listserv and on our website after the call as normal. And just a quick mention that the views and opinions expressed in this presentation are those of the speakers and do not necessarily reflect legal advice, views, or positions of the Produce Safety Alliance. Next slide, please. So I wanted to set the stage with a couple of slides as we begin, because one of the things that Sean is going to be talking about today is a number of great hydroponic and aquaponic resources that the Northeast Center to Advance Food Safety, or NECAFS, has been producing. And some of those resources are related to tailoring the content of PSA grower training curriculum and tailoring that delivery for hydroponic and aquaponic audiences. So he's going to be discussing supplemental HPAP material that has been developed for these specific audiences. And I just wanted to give everybody a reminder of what the PSA policy is for tailoring those materials. And I wanted to mention this right up front because we have been getting some questions from other PSA trainers about these types of policies. So this material that Sean is going to talk about does fall under the allowable modifications policy in PSA policy. And just as a reminder, all PSA trainers are allowed to utilize this policy to make the delivery more effective. And I have some details in the next slide. Thank you, Betsy. So just as a reminder, all of this is available on the PSA website under the Train the Trainer manual. But the modifications that PSA allows to the grower training course is that anybody can change photos but not text. Just as a reminder, when the grower training course was finalized, we went through a pretty extensive review process. So you can change photos but not text. And a lot of times those photos are changed to reflect regional, commodity-specific audiences or other preferences. So in this case, HPAP. You can modify the training agenda as trainers to reflect a multi-day program. So a lot of, in these days, we do this a lot. If there is a remote course, people tend to prefer like a half-day remote course over a full course, or a full day. So you can modify that training agenda. But the requirement is that all slides and modules are covered during the training and that you can track participation to make sure that all of those participants have been presenting each of the modules. So some of the examples is this includes adding supplemental slides and interactive activities. Sean is going to show some of those supplemental slides today, but there are other options that have been developed and are available under trainer resources on the PSA website. Next slide, please. So with that, I'm going to jump into introductions. Feel free if you have any questions, again, ask them in the Q&A or the chat. But now I'm excited to introduce Sean Fogarty. He is a research specialist at the Northeast Center to Advance Food Safety, or NECAFS, at the University of Vermont. And Sean has been a research specialist since 2020. And his focus at NECAFS is on on-farm produce safety with research and extension lenses. This work includes helping to coordinate regional research initiatives in developing educational resources for growers, educators, and regulators. And I know within this role, he's been spending a lot of time with hydroponic, aquaponic. When I get HPAP questions, I tended to kind of give them to Sean. And before serving in this role, he earned a master's degree in agricultural sciences at the University of New Hampshire, conducting research in large-scale aquaponic greenhouses. And he has found a warm and welcoming community in the food safety world, and thanks you for joining us today. So with that, I am going to hand it over to Sean.
Thanks, Donna. I'm gonna share my screen. Let's see. How's that?
It's so maybe it's not me. It's taking a minute, but we see topic-based fact sheets.
Okay, great. All right, so welcome everyone. Thank you for coming this afternoon to our webinar on hydroponic and aquaponic produce safety. Let's see. This is slide 8 because I was in the middle of the presentation when I started. So let's go back to the beginning. Okay. So this is a project that's been in the works for a few years now. I want to acknowledge Chris Callahan, Elizabeth Newbold, Andrew Chamberlain, Hab Machado, Sujata Sirsat, Lori George, and Elizabeth Bin for their instrumental role in developing the resources that I'm going to talk about. So I have 3 goals during this presentation. Firstly, I'd like to provide a brief introduction to hydroponic and aquaponic operations for people who might not be familiar or if you need a refresher. And throughout the presentation, I will shorten hydroponic and aquaponic to HP/AP. It's a lot less typing. Secondly, I'd like to help spread awareness of the resources that we have available to support educators when you're working with HPAP growers. And so I'll go one by one through this list. And finally, I'd like to convey some high-level produce safety considerations that are specific to HPAP operations. And there we'll get into some of the content of this tailored material for the curriculum that Donna talked about. So the lines between these different goals can be blurry. So there's some overlap as I go through, but I added a little progress bar at the top. So if you zone out or if new people join, they can tell where we are in the presentation. And finally, we'll have plenty of time for questions and discussion. All right, so to start off very basically, I'm going to define hydroponics. So it starts with water. That's sort of one of the central components of hydroponics. And so we add nutrients for the plants to that water. It becomes something we call nutrient solution. And this is sort of the most basic recirculating hydroponic system you can draw in this sort of schematic view. So we have a pump that draws the water to a hydroponic production unit. There are a lot of different kinds of these, so I'm going to talk about what those different kinds are. And then in this one, it flows back to the reservoir and mixes with, you'll probably add water and new nutrients to sort of balance out that solution over time. So there's a big diversity of system designs. The first one here is called flood and drain, or an older term is ebb and flow. So as you can see, we've got all these vertical racks. They're growing microgreens here. This is inside a warehouse. And the nutrient solution reservoir is on the bottom, these black and yellow tubs. And in each rack, there is a pump and piping to pump that nutrient solution to the top. It fills the big tray, which floods the root zone of the plants, and then by gravity, it flows down to the other trays. So this is one of the simplest systems that you can design in hydroponics. Nutrient film technique or technology, people call it different things, but NFT for short, is where we have a small, a film basically of water that flows down this channel past the plant roots. So the volume of water is much less than in some other operations. As you can see here, we've got surfaces that are in close proximity to the growing produce, and that'll come up later. Deep water culture. This is actually my aquaponic greenhouses at UNH. And these beds are about 10 inches deep. So the rafts you see are floating on top of 10 inches of water. And we also have fish tanks over in the corner here. And so this is all part of one system. And I'll describe in more detail what aquaponics is a little bit later. This type of system has a very large volume of water, and I'll mention some of the reasons that can be good or bad in a little while. Drip irrigation is also a very simple form of hydroponics. In this example, we have cherry tomatoes growing in what are called Dutch buckets or Beto buckets. So the buckets are filled with perlite, and then drip emitters are stuck into the perlite to deliver the nutrient solution to these plants. And so as you can see here, we've also got a lot of plastic surfaces near the produce, some metal surfaces as well. Media-filled beds is used on small scales. This is not a super scalable sort of design, but it uses, this looks like pretty much a traditional potting mix. And then we have water introduced at one end and flows down the bottom of the substrate to the other end. And then just by capillary action, that water gets drawn up to the plants. And so this is also a very simple sort of system, but it has a lot of this organic media in it. And managing that can be problematic sometimes, which again, we'll talk about some more details later. Another type here is a vertical gutter. So this is inside a shipping container. That's why the space is very narrow. And there are a lot of us in close proximity here. So we have, I think, ABS plastic channels that hold foam strips and a wicking strip. And those foam strips keep the roots in place, and then the wicking strip draws nutrient solution from the top of each channel to the bottom. And then we can see someone here is harvesting, and they actually have cut and come again herbs, so they can get multiple harvests out of each plant. All right, finally, this is a larger scale type of operation called a mobile gutter. So you can see here this long gutter of plants that are about to be harvested. This gutter was brought by automated robotics from the greenhouse into the harvest and packing facility, which is a big cool room where the robotics actually push this through harvesters and all the way to where people finally do the final packing. And this is done at very large scales. This is from Little Leaf Farms, and this is a 20-acre or 10-acre greenhouse. I think it's 10 actually, in Massachusetts. And new types of systems are in constant development. I was at an indoor ag science cafe last week from the CEA Alliance, where someone was presenting about this entirely automated growing system where every 2 weeks you put in the inputs and it does all the growing for you. It was really amazing. So people are coming up with new things all the time, which makes our job harder, but also more fun because we get to sort of chase around what the different produce safety considerations might be in all these different situations. All right, so here's another schematic view. This is the NFT or nutrient film technique sort of system, and that here's the hydroponic unit here. But I wanted to show this to show how many other components and activities might be happening in an operation. So this example has a slow sand filter to get the particulates out of the water, a UV filter to kill microorganisms in the water. And then we've got multiple nutrient stock tanks that people have to manually measure out the nutrients and fill. And then we have a mixing tank, and this is all one big loop. But also we have someone doing water quality analysis, someone doing some harvest and packing, and then someone over here is cleaning the NFT channels themselves. So we have the potential to have a lot of activities happening in a small space and sometimes in an enclosed space, all with each other. Now this one is an aquaponic schematic, and most of it is the same. So most of these activities down here are the same as the last one, so you don't have to be overwhelmed by that. But what's different in this one is the deep water culture pond. As I mentioned earlier, it's used in aquaponics, and part of the reason is that with the large volume of water in deep water culture, you have a big buffer against environmental changes that might impact the fish health. So the other difference here is that we have a fish tank. So a different input is fish feed into this system, and then also fish feces and fish gill exudate, which is their form of urine. Um, we also have different types of filters here that are appropriate for the aquaponics system. So aquaponics can add complexity and more human interactions with the systems. Um, and so it's even more things for growers to keep track of. All right, so Donna introduced NECAPS, the Northeast Center to Advance Food Safety. If you're unaware, we are one of 4 regional centers. We were funded by the USDA after FSMA was signed into law to support outreach and education of producers and processors impacted by FSMA. Our outreach and education also extends to regulatory partners and educators like yourselves. So we try to help facilitate outreach and education to growers indirectly that way. Um, Back in 2019, our network identified a need for educational resources about produce safety in HPAP. This is a quickly growing segment of the industry with ambitious goals for long-term future growth. So the importance of produce safety in these operations is only going to increase over time. So the first approach we took to meeting this need was to develop a series of 5 topic-based fact sheets that take produce safety practices and start to describe how to approach their application in HPAP operations. And based on the response to the fact sheets, and we observed this sustained need in this area, so we applied for and were awarded a USDA NEFA Food Safety Outreach Program grant to continue this work, which is a lot of what I'm going to describe to you over the rest of the presentation. All right, so these are the covers of those topic-based fact sheets. We covered 5 topics that overlap a lot with the modules in the PSA training for good reason. These are some of the key things. You'll notice that water quality management is not in this list because at first we did what we had enough knowledge to do, which was to give some recommendations on these topics. Water quality is a more challenging topic and needs more research behind it before we can make specific recommendations about how HPAP growers should manage it outside the requirements that are already in FSMA. After those fact sheets, one of the first things we did as part of this project was to create an intro to produce safety for HPAP growers document, or what we call the 101 guide for short. And so that's on this next page, and it focuses on water, systems, people, and fish. So these are specific considerations that we pulled out that require extra thought or a different approach to education when it comes to produce safety and HPAP. And so these are sort of the themes that we'll pull through the rest of the material. All right. Also, back in 2023, we did some introductory webinars. These go into more detail than what I'm giving here because we broke out the content into even smaller chunks. So firstly, we have an introduction to HPAP systems. So if you're unfamiliar with these types of operations, that's a good place to go for a 60-minute introduction with questions. To just sort of what's going on in these operations. And so the second presentation was more geared toward those who are familiar with HPAP, at least some, but not with how produce safety might be applied in those operations. So that leaned heavily on our fact sheet content, to make some basic high-level recommendations. And we've learned a lot since then, and the new subpart E also dropped during that time, so we're excited to present some more up-to-date resources as we move along. All right. Grower case studies are one of the most fun outputs from this project. The first one we did near the beginning was at Legacy Greens in Tallahassee, Florida. So this will look familiar. It's the flood and drain microgreens grower. They grow in a warehouse that they share with another company. Um, and so they have an interesting en environment surrounding that operation. Olivia's Garden is in New Gloucester, Maine. This is an NFT operation in a greenhouse, and they grow basil, lettuce, and pea shoots. And so we can see here, they actually do sort of a modified deep water culture in order to grow their seedling plugs. So they can grow the seedlings very densely in this system in rafts that have holes that are close together. And then these get transplanted into the NFT system. So you might have multiple types of hydroponic system within one operation. And now Get Block Farms, this is another familiar photo. They're two insulated shipping containers in Aliquippa, Pennsylvania. And they grow a wide variety of crops. They have these herbs here, they do leafy greens and also root crops. So they are growing things like Parisian carrots and Harukai turnips in these vertical channels, which I was really impressed with. Oh, I should go back and mention that this is the link to our main project page, which is that 101 guide. There are links to everything else that's available on that page. You might have to scroll to the bottom to find some of the links because UVM redid our web pages and it sort of messed up the formatting. But this is where to get everything for this project. go.uvm.edu/ponics. All right. So this is leading us toward the PSA curriculum. Um, we recognize that there were some terms that we were using in our supplemental materials that weren't defined in the original PSA glossary, which includes those definitions from the rule. And so we created a supplemental glossary. So this collects definitions from various sources. And as I said, mentions, it includes undefined terms that we found we needed to use. We actually just now, the CEA Alliance, which I mentioned, is an industry group that has expressed interest in collaborating to help standardize terms. And we've just received some detailed feedback from them on the glossary. We haven't had time to digest that or respond yet, but my hunch is that we'll incorporate those suggestions to get a revised version out this summer. Okay, now to the what you've all been waiting for. I meant to take this text out here. What I mean to say, this is a PSA grower training that we tailored for hydroponic and aquaponic operations. And so you'll see here, we just added this with hydroponic and aquaponic supplements. So everything that is in the original PSA grower training is still there in place. We just added to it. We had a couple of goals with these tailored materials. The first was to help HPAP audiences feel represented in the materials themselves. So seeing photos that are familiar and examples that ring true. And secondly, to understand how to apply produce safety practices to their operations. So what's different? This is sort of related to one of the slides Donna showed about what you can do in when you're tailoring the curriculum for a specific audience. So what we did was to swap out photos. We added supplemental notes, which also, when it was appropriate, included additional resources for folks and references for the information we're including. And then when when it made sense, we added supplemental slides. So two examples of these that occur in every module are an HPAP learning objective slide and a summary slide. These supplement the original PSA learning objectives, and I'll talk more about that in a minute. But we also included extra slides throughout the modules to translate info to HPAP, to provide examples, and to sort of draw out those concepts where we need additional emphasis. And then the glossary that I just mentioned is included in this tailored manual as an addendum to the original glossary. So for these HPAP learning objectives, the content that you'll see in the modules is that each module has a learning objective slide. And the purpose of those is to indicate, let's see, there we go. The purpose is to indicate some key considerations which complement the pre-existing learning objectives. So we weren't trying to redo anything, rather to sort of give you information on what to really focus on and emphasize in each module. So for this part of the presentation, I'm going to go module by module and just share with you the learning objectives that we came up with and a little bit about some of the supplemental slides in those modules. So if you think back to the 101 guide, I briefly mentioned that we sort of pulled out water, systems, people, and fish as these key differences that can occur in HPAP. And that water and surfaces in the system can become contaminated. And then potentially that contamination can spread to everything else that's connected by water, by direct contact, or by human activity. And HPAP operations are often in constant production. So this means that they're growing large volumes of produce that move quickly through a relatively small area. For that reason, we found that standard operating procedures are especially important. These are always important for growers, but we emphasize their value to HPAP growers because, as I mentioned just now, an individual contamination event has the potential to spread and to put a production system out of commission. With the cost of space and inputs and time for these growers, they cannot afford to fall down on worker compliance. And that leads us into module 2 about worker health, hygiene, and training. A lot of the material in this one is applicable just as it is. You know, training workers looks similar in a lot of different scenarios. But here we focus on the people and what's different about HPAP for them. So washing hands is probably the most important activity, I would say, that the workers do in an HPAP system. This is not only for produce safety, but also for biosecurity to prevent plant disease, for worker health. And so hand washing is number one here because of that interconnection of systems. We have sometimes recirculating water that can spread something, proximity of different activities, and water is everywhere. And then because of this system components like air and water pumps and other machinery, there may be specific worker hazards like constant noise. If you're in a greenhouse, heat and humidity can be a big problem in the summer. Chemicals, everyone has to deal with potential chemical hazards. And then handling fish can also lead to injury. So we just want to make sure that owners and supervisors understand that they have to provide appropriate PPE, personal protective equipment, to protect against, to protect against injury and illness. This isn't a FSMA thing, but worker safety is important for produce safety. And so we link to some OSHA resources for more information. All right, module 3. This one has given us the most grief because it's about soil amendments, which soil and soil amendments don't often exist in hydroponics and aquaponics. But we took a sort of risk reduction lens and looked at what are some parallel potential sources of contamination and parallel situations. So this shows here a sort of crosswalk slide that we developed for the beginning, where we show a plant in the soil and different things that can impact it. And then we show how that is different in hydroponics and aquaponics, where the inputs go into this tank, not into the soil, and they don't get influenced by the soil in the same way they would in out in a field. So some of these equivalent pieces, I've said substrates a few times now. So substrates are soilless growing media, and they act as a physical anchor for roots. They can provide air and water holding capacity as well. And then the nutrient solution, as I mentioned earlier, is irrigation water that contains the plant nutrients required for the crop. And finally, fish waste. In aquaponics, we have both the liquid fish waste that comes from the gills and fish feces. The feces is often put through a mineralization process, which breaks down the organic matter and releases nutrients for the plants. And then that process waste is often returned to the system. And so it's really important for us to understand where that water and those waste materials fit within the framework of FSMA and just risk reduction. So we we are still working on exactly where we will land with making equivocations between, say, soil amendments and substrates. I think we're going to come up with something that shows the parallels without trying to make equivalences between things in HPAP and things that are described in subpart F and around soil amendments. I feel like this might end up being a big topic of conversation. We'll see. Module 4 was a bit simpler, but still has some complexity to it. So one big thing is that your animal management practices and what's required will differ depending on what type of structure, where you're doing production, harvest, and post-harvest activities. So if you're in a fully enclosed structure, which especially in colder climates, I'm in New Hampshire, operations are often completely contained. And so in those situations, a pre-harvest assessment for animal contamination may not be required, but pests must be excluded. Whereas if you're partially enclosed or outdoors, we go through what will growers need to understand about managing wildlife. There are more similarities here with field crops, and so many of the recommendations in the original material will apply. And now these next two objectives are about fish. The first one is about fish stress. Now fish aren't covered by the rule, but fish health can impact plant health and produce safety. So we talk about ways to reduce fish stress, which enhances their immune systems. We also point out some potential hazards of having fish tanks in the same room or in close proximity to crop production, and how folks might take measures to prevent cross-contamination in that situation. All right, ag water. This is another tricky topic, but I think we did a pretty good job. So because there's water everywhere, it may contact produce both during and after harvest, but also before. And so the definition of ag water is really important. Contact can happen whether it's intended or not. In this example, I would not say this grower intends for the irrigation water in these deep water beds to touch the growing lettuce on top, but it definitely did in certain circumstances, on the edges especially, or if you have large plants that grow to the point of hanging into the water. So it's really important for growers to be able to classify the water in their operations in the different ways they use it. We also talk about ways to prevent contamination of pre-harvest ag water. So you have, in a lot of circumstances, water that's pulled from, say, a municipal source, but is then stored and um, on land for long periods of time. And so preventing contamination of that water is really important to keeping your system safe and clean. And then depending on the setup or how much the grower has already invested, they can potentially change the status of the irrigation water to be non-ag water if they can prevent that contact. So we try to explain this and we recommend this as the best way to prevent contamination through contact with water when it's an option. If you can sort of rule things out as ag water, then that's going to make things simpler for the grower. And finally here, which I'll talk about in Module 5.2 as well, when you harvest crops with roots attached, post-harvest water quality requirements apply no matter what. And I'll explain that on the next slide. All right. So let's see. We start in 5.2 by emphasizing the importance of growers making accurate determinations around the different water uses and then how they're classified under the PSR. So that's this first bullet here. Also, we bring up that the term water treatment has already been in use in the industries for a long time, and it can refer to system components that influence different aspects of water quality. However, the focus is usually on operational needs like crop nutrition and not on produce safety concerns. So we delineate between the water treatment that many growers are already doing um, and what is meant by treating ag water in the PSR. So that's an important distinction for everyone to understand. And then finally, getting back to the sort of roots on and when post-harvest water or when pre-harvest water can be post-harvest water. So the nutrient solution in a lot of systems can come into contact or maybe likely to contact the harvested portion of the crop. Like I described in the deep water culture system, you might have constant opportunities for contact, in which case you definitely have to classify that water as post-harvest water. And so in this module, we try to help growers beyond just classifying the water to understand the specific hazards of harvesting with the roots attached. And that can be um, the primary thing we worry about is then once that thing has been harvested with the roots on it, are the roots dripping or even touching the edible part of the produce? Sometimes this is called live harvest. So the water in that root substrate plug is definitely post-harvest water. And if growers find themselves in this situation, they can choose from a few options if they're determining that the water in their system is post-harvest ag water. So firstly, they can manage their crops physically to prevent contact, such as with trellising or using a different growing system like NFT, where you have protection from contact. In the case of roots on harvest, however, that's not going to change anything for you. They cannot harvest the portions that contact the water, or they can manage the water as post-harvest water, which um, some of the growers in our pilot delivery, which I'll mention soon, said that that's what they were going to do because it makes things simple for them. All right, module 6. So one of the big differences here is that we extend the consideration of cleaning and sanitizing beyond the pack house. So in soil, you don't usually have surfaces close to the produce during the growing period. However, in HPAP, we often have multiple types of surfaces in production areas. And if these surfaces are intended or likely to come into contact with the harvested portion of the crop, they are food contact surfaces or zone 1. So then you see in this example, we move out from zone 1. Growers will have to consider the potential for cross-contamination from these other zones to the food contact surfaces and the produce during harvesting, packing, and holding. And then on the second bullet, due to the importance of being able to clean and sanitize food contact surfaces, we introduce HPAP growers to hygienic and sanitary design principles. And we provide a lot of links to external resources there. And as came up earlier, we have crops, people, water, surfaces, maybe fish in relatively small spaces. So we emphasize identifying these opportunities for cross-contamination when you have different activities occurring in adjacent spaces. Module 7 is easy. Food, food safety plans are similar regardless of your growing system. So we didn't add objectives, we didn't add notes, but we did replace photos where appropriate. All right, we're in the home stretch here. So as I mentioned before, we had a pilot delivery in May. We had 8 trainers and 26 students, which was a good mix. We had mostly growers, but also some regulators, consultants, and educators. And it was really valuable to have several types of perspective in the room. This led to engaging discussions, which didn't only provide us feedback, but also helped the pilot growers and the trainers to better understand the material and how to deliver it effectively. Um, we also timed that delivery to provide some guidance. And for those of you wondering, we added about an hour of active content delivery time over the course of the whole curriculum. We actually did this over 3 days so that we could put in time for feedback and discussion after every module. And that worked out really well. But I'm guessing for future deliveries, it will have to be over at least 2 days, unless you want to do one really long day. We also created a pre-post test, and then we validated it. So this evaluates knowledge change based only on those HPAP learning objectives that we went through. And so you would use it in addition to the standard PSA evaluation. And these are just the average change in correct answers from pre to post among our different cohorts. So we had an average of about 10% increase in knowledge over over these learning objectives from the supplemental content. So how do you deliver this? Where is all this stuff? So we have a dedicated NECAFS webpage that is now just a placeholder, but it will link to all the needed materials when they're complete. And this includes one really important resource, which is the Trainer Companion PDF. So this is for you all, for anyone else who's going to deliver this tailored version of the curriculum in the future. And it sort of goes over in more detail, how did we modify things, how to approach using those slides. It goes through all of the learning objectives, but also provides key learning points that are related to those objectives. And then we have some logistical stuff in there too. Finally, the slides are in a final round of revision now. We're talking with Donna and the rest of the PSA team about storage and where we're going to actually host these completed materials. But our project ends August 31st, so it'll all be available by then. All right, any questions? I see a bunch of them popped up in the chat.
Yeah, so thank you, Sean. I really appreciated sort of going through and seeing some of the supplements. Okay, so there are a couple of questions. Everybody else, feel free to feel free to ask questions in the chat box or the Q&A. I have a couple I'm going to start with that I saw come up earlier, and then I'm going to hit the Q&A and then Leah's question. So Mike asked a little bit ago, are there steps in HPAP production activities where gloves are generally used?
Yes. Let's see, I need to stop sharing so I can see the Zoom window. So let's see. Gloves are often used in all of the steps, depending on the operation. We included a slide in module 2 about proper glove use. So there wasn't a a whole slide devoted to gloves in the original. So we pulled out the glove related information from the rule and included that as a slide to emphasize what you need to be doing to maintain those gloves if you're using them.
Thank you. Okay, so I'm going to hit the Q&A question next, which I think is fascinating, and I'm curious because I do not know the answer to this. So they mentioned you mentioned fish feces often go through a mineralization process. Is it truly manure or feces then, or is this the
Hmm.
HPAP composting version? Since you can't compost that type of waste via a traditional composting method, turning temp, etc. I was talking with a grower who got really frustrated when I framed it as manure and argued that it's not manure at all. It's an extremely refined process. What is your take on that? And could you dive into more details on the differences in module 3? I think you alluded a little bit to this of it's complicated, but
Yeah, those mineralization processes are not standardized across operations or designs. And so I really have not seen consistent enough processes to say anything about um, whether they might reduce foodborne pathogens the way composting does. We really need a lot of research if we're gonna try to argue that. Um, and to the point of saying it's a more refined product, sure it is. But how are you managing that product, and how is that influencing the microbial growth and sort of what microbes are hanging around in there? If you're preventing contamination completely, um, then there are no human pathogens in fish feces, just like endemically as a matter of course. Um, Human foodborne pathogens are typically only introduced into an aquaponic system from a person or a contaminated input. And so the fish themselves, I should have backed up and said this first, the fish themselves don't pose an ongoing produce safety hazard. It's more what can grow in that feces when it's being held and processed on land.
thanks. I can imagine with the humidity, that you have all the factors for once it becomes contaminated to help with that cross contamination. But to me, it seems a little bit almost like vermicompost, where we talk about it's really difficult because it is, as you said, it's not a consistent standardized process like we have
Mhm.
windrow composting, whatnot. Okay,
Yeah.
thanks.
And I
Oh,
mean, that was sort of part of what I was hoping to do in my master's research was actually to validate a process. But what I mean, it was ultimately trying to validate the whole system as
mhm.
a treatment process, which is very challenging.
Yeah, yeah. Okay. Okay, I'm going to jump back into the chat box. So Mike also asked, are there problems when fish die during HPAP production that needs to be addressed?
Yeah, I would say if you have like one fish die, but the rest of the fish look healthy, that's not an issue. You want to remove that fish as quickly as you can from the tank so that it doesn't start decomposing and become a possible issue. Um, but then if you have multiple fish deaths happening, there's something wrong in your system design or the way it's operating. And so that's a really big red flag to aquaponic growers about their overall water quality management because fish are very sensitive to changes in water quality, more so than plants a lot of the time. Um, and so fish death might just be a one-off. It might be a sign of something systemic.
Okay, I'm going to jump down to Leah's question. So their question is asking more about actually using it, and then I'll jump to Billy. So a couple of like usage questions, how to use these slides. Can we insert some of the hydroponic slides along with the traditional FSMA training? So I think they mean instead of going whole hog into
Mhm.
using all of the supplemental material, can they pick and choose?
Yeah, I mean, definitely. As long as you're following the policies that Donna laid out at the beginning, um, you can totally pick and choose. The only downside there is, or one of the downsides there is that we added supplemental notes to almost every slide. And so if you're picking a few slides out, you'll miss the sort of bigger context of all the notes in the module. But a good sort of shortcut for folks might be to look at the summary slide and see if you are including the points that are in that summary, or whether you're missing some of that because you don't have all of the supplemental notes.
Thanks. Okay. So I'm going to go to Billy's question in the Q&A. Just to clarify, would you suggest scheduling an extra hour of presentation time if we decide to incorporate the slides?
Yes, I would say at least an hour. The stuff we added tended to prompt a lot of good discussion. And so depending on how lively your group is, you may need even more time than that. So one thing I'm going to recommend in the companion document is to allow that time, because those discussions in the feedback afterward were the most valuable part for most people.
I'm sitting here while you were talking, trying to visualize some of the like hands-on activities. And I don't know if anybody who have maybe attended an in-person grower training course, but we have a poop pillow activity we used to use. And I'm just picturing like taking a big old bucket of water or something to kind of mimic cross-contamination. But okay. Okay, so there's one more Q&A question. When will materials in Spanish, will the materials be in Spanish when finalized?
Unfortunately, we won't be translating them into Spanish. You know, I had ideas in mind of an FSOP project that would succeed this one, and it would include delivery and further refinement of the materials, but we're not we don't have an RFP out for that. So unfortunately, we don't really have any more capacity to work with these materials after August 31st, at least for now.
Thanks. Okay, so there's a couple more questions coming in. Okay, so any thoughts on clean breaks in aquaponic systems?
Ooh, that's a challenging one. Um, in most cases, aquaponics systems are run for as long as they can be before they are cleaned, because over time you develop this microbiome that it's thought it can be beneficial to plants. It can help them to take up certain nutrients, but it also can exclude pathogens when they're introduced potentially. And so the idea is that there's no niche space if a pathogen were to come into the water, um, and so that it would just die off on its own. I honestly, it's hard to envision how you would do clean breaks in an aquaponic system. We were considering building one on an island here in New Hampshire that didn't have like people on it all year, and so they wanted to do it only in the summer, and we could not figure out how to help them make that happen.
Thanks. And it seems like, Sean, to clarify, so the clean break is usually, that documented cleaning and sanitizing step before to have a break from that lot, especially for traceability purposes. So sort of to extend that comment, would you normally find it at the end of that production cycle? Or so whenever those I guess I'm thinking of like a one cut operation where you would harvest and then in theory they could clean, sanitize, record that cleaning and sanitation step before it goes back into production.
Yeah. So if you're just thinking about the like post-harvest process, you can definitely introduce clean breaks there so that you can prevent any post-harvest contamination from happening. But when it comes, I guess I was talking about and thinking about actually the inside system surfaces themselves, which are covered in biofilm. And
Mm,
yeah, as Valerie says, a 7+ year continuously running system, um, I, that part is it
I see.
someone would have a really great product if they could figure out how to make it happen. It's just hard to envision.
Thanks, Sean. I think that kind of demonstrates how complicated and individualized some of these systems are because I was
Yes.
thinking about floats. Like I was thinking of the, like a float, like the rafts, cleaning and
Hmm.
sanitizing those. Excellent. Okay.
Oh, and yeah, wasn't there a question about cleaning and
There
sanitizing
was,
rafts?
so there was a question, what frequency do you recommend for cleaning float rafts? Do they have
Yeah.
to be cleaned? So,
So I'll start with the second question. Do they have to be cleaned? Um, if the harvested portion of your crop, say a head of lettuce, touches the top of those floats, then yes, that's a food contact surface. However, if you're not harvesting the roots, the bottom part of the float isn't a food contact surface. It's more like a zone two. Um, and so we don't really have evidence-based recommendations for this, but what we did at UNH was after harvest, we took the floats out, scrubbed the gross matter off of them, and then rinsed them off, and then sprayed them with Sanidate on both sides. And so that helped to reduce biofilm buildup on the rafts themselves, and also take care of cleaning and sanitizing that top surface.
thanks, Sean. Okay, so we have a couple minutes left. So I'm gonna pick, let's see. I'm just gonna summarize in the chat box. There was a question about related to harvest water and post-harvest, yeah, harvest and post-harvest water related to harvesting with the root of the plant. And Elizabeth put in a fact sheet. I think that addresses that question. One
Mm.
of the fact sheets that was developed by this project. So I think there was one more question in the Q&A. If fish feces are not themselves a source of human pathogens, would it make sense to focus instead on avoiding contamination of the material versus worrying about an analog to composting, meaning to focus on the PSR requirements currently meant to guard against recontamination of treated compost?
Um,
I-
I'm gonna say yes, but with some qualification. We actually need to figure out whether that processed fish waste would be considered under subpart E or subpart F. And FDA has not been totally clear on this. Their comments in the preamble to the FSMA are don't give us a conclusive answer to like where does this fall in the regulation. And so it seems to me like as more and more aquaponic operations are inspected, um, some sort of like shared understanding has to shake out eventually. I'm just sort of wondering, without us doing this work, how is that going to happen?
And yeah, I was gonna say, I think maybe the short answer, recognizing we have a minute, is it's not totally, there's not an analog in terms of the
Yeah, like
monoamine
I wouldn't make a
composting.
direct, like, I wouldn't say, yeah, treat this the way they describe treating compost in the rule. I definitely wouldn't make that recommendation at this point.
Excellent. Okay. Thank you. Thank you for all the questions. I will say if you have additional ones, you can continue to send them in. We can send them to Sean. I do, if my share is working, I have a
Oh,
quick.
I have to stop, or I did
Oh,
already. Sorry.
you did.
Go ahead.
Yep.
Yes.
Yep. Nope. Let me just quickly share screen. We're gonna see if it works. It was not working.
I'm
Oh,
ready if you need me.
thank you, Betsy. Can you share? I just really wanted to give a quick update in terms of PSA. We do have a new version of the PSA Train the Trainer manual, version 4.0. So I will drop the link to the English version in the chat box. It's available in English and Spanish. And really the update here is I find this as a trainer, like even earlier, we talked a little bit about modifications to your delivery of the grower training course. Those types of policies are included in this Train the Trainer manual. So even though I'm guessing most of you have attended the Train the Trainer course previously, I tend to keep this as a trainer just on my desktop to look at policies. And just a couple of updates there. And yes, so I will put the link to the chat box, put the link into the chat box. And next, please. I will also be sure to include it in the follow-up email to this webinar. So just a couple of other things here on the screen, you can see we have a number of social media accounts that we maintain. So just a reminder, We are working on setting up additional educators calls, so stay tuned. We will send out an email. They were not quite finalized for this course, so you will see those registrations coming through. We have a couple of, I think, exciting things lined up. But yes, so we have accounts on Facebook, Instagram, LinkedIn, and we've also been sending out pretty regular newsletter emails as well. So just a big thank you. Thank you, Sean, for your presentation today. I know I learned some things and jotted down some notes. And thank you all for your questions. So with
Thanks,
that, I
everyone.
would, yeah. Thanks, Sean. Have a nice afternoon, everybody, and enjoy. It's this very warm here, so enjoy your warm summer afternoon.